the mean, you have to find the eigenvalue and eigenvectors. How to find eigenvalue, eigenvector? You have to be able how to do it.
You said you find S multiplied by the mean. What's the mean?
How to find the SB? It is same thing in the class, in the lecture, I call it B. What is B? I put S and XB. So, clear here? After it became easy, if you find the eigenvector, after finding the eigenvector, what we need to do? After finding eigenvectors, you have to multiply out, you have to do the projection, right? What is projection, please? In what is equations? We have the W is eigenvector, you multiply it by X. X is the entire data. What is it here? Mean is X minus and X plus. That's all the vector, which is the size 2 by 4, which is here. It is not clear. Yeah, you can see. Okay, and you multiply. You get a new value. You get 4 values. Those 4 values should be on this direction. You can see the plus and minus are clearly segregated. Here, please, another question. Giving the label point here, find the best linear dominant line W. Okay, from the data, we can find all the coordinates or not? From the plot, can we find all the coordinates?
Yes.
Yes. How many classes do we have?
2.
2. Triangle and circle. I can find mu1 and mu2. Can we find the mean?
Yes.
Of each one, right? So mu1 and mu2 are easy to calculate. Can we find the matrix B, which is mu1 minus mu2 times mu1 minus mu2 transpose? We find the matrix. Clear? From the data triangle and circle, can we find the covariance matrix? How do you covariance matrix? The matrix minus the mean to make a sentence. When you finish, you take this matrix, you multiply by itself transpose. You get your covariance matrix. The same thing for the other class. Yes? Please tell me yes or no to repeat. Yes. So we have in 2 classes, we can use S minus 1B or shortcut, just you need to calculate, S, where is the mouse? Yeah. S minus 1 times mu1 minus mu2 is your W. When you have the W, you do the same thing, projections, you get a new data. But according here, can you guess what is the best W direction here? This one. Just guessing. Do you think this line?
No.
This line?
This, yes.
Yeah, I think that this is the best one, right? It will be here, totally the separation here, right? So we have S. I just apply any language for find eigenvalue, eigenvectors. Yes? So according here, what is the best direction here? This is the eigenvalue, right? And this eigenvector. So you see this is the best one, which means this direction. Or not? Minus means this direction, right? Of course, the eigenvalue, the eigenvector, it is not for S minus 1. Please be careful. The eigenvector is for S minus 1 times B. Here, I am giving you S minus 1 in order to calculate this one, okay? Is it clear? No. Okay, so please here, how to proceed to find the new projection data? How to find W first? Are you able how to find B or not? What is the formula of B? Mu1 minus mu2 times itself with transpose, right? We have the B. How to find S? S is the sum of the 2 covariance matrices, yes? To find the covariance matrix, what you need to do? Your data should be set it as 0. Correct? Do you know how to do it? It's just your matrix of your class 1 minus mu1, 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 mu1 according to the size of it. When you difference, you'll find the matrix. This matrix multiplied by the transpose of itself is covariance matrix. You do the same thing for class 2. And you do the summation, you get your S. No, S we call it. So S minus 1 times B is a new matrix. The new matrix here find the eigenvalue and eigenvectors. The principal eigenvectors is your directions. You will find W, you multiply with the transpose, you multiply it by your entire data set, you get the projections.
Doctor, is it possible to write the steps?
Yeah, I'll do it. It's on another slide. I'll give it. But just here, try to follow me the steps to understand why. Okay? Here, just putting this matrix, we have everything. So you have S minus 1, you have mu minus mu 2, so you can calculate, you can get the direction. W is, this is, we do it next time. It's just matrix equations. I will give something else. Just a second. Okay, look at linear or LDA finds a space of lower dimension by choosing the direction where the data varies most. Correct or wrong? True or false? So I'm giving sometimes the wrong answers. So what do you think? LDA space is lower dimensions by choosing the direction where the data varies most. This is seems what? Seems PCA. It is not LDA. Clear? So he's wrong. Second one. Numerical computational here for PCA and LDA.
Doctor, what is the main difference between PCA and LDA?
Okay, what is the main difference? LDA, we are taking consideration of the label in order to find the classification. What we are trying to do, we are trying to minimize the variance of every cluster and maximize the difference between the mean. In PCA, a different story. We are looking for which features that the variance is bigger. Regardless, label 1 or 2 or class. We don't care about classes.
I mean, in which case we should use LDA and in which case we should use PCA?
Who can answer the question, please? Here? LDA in one of the classification. PCA, compression or feature selection, if you want. In understood. You see something like this. Clear? To compress your data. Okay? But you can combine both of them to get something better. Okay? So here, for example, here, the problem here when you have matrix dealing with images, in order to find the inverse of matrix is really difficult. Right? So the idea here, instead of using ATA, we use A80. So here is as we did in SVD. So I come back to this example later on. Just giving the flavor of things here. Okay, numerical computational, here I'm proving it, why it is important. Here, for example, you can see the questions or not? I don't know why it is not. Okay. For example, here, consider the following data of the two classes. Do you think which of the following model, but without additional, can achieve zero training error for classification? Means you can discriminate between the two, blue and red one. Do you think we have to use LDA or PCA? Definitely, PCA is not in the classification, right? Do you think we can do LDA?
No. I don't, where is the direction?
Okay, according to what we study until now, when we do the LDA, we have only threshold, yes or no, up or no, right?
Yes, we can.
But here, if we do in these directions, for example, or this one, we can segregate between the two, right? But I will have blue, red, red, yes or no?
Yes.
So we have to do a little bit more decision, not only one decision, right? Not bigger, yes, and low is two classes, right? So we have two things. So the normal LDA doesn't work. We have to do extra. Yes, but we can, it helps a lot. It helps a lot. They are separated. Blue, blue, red. Or the other side, up to you. Okay, which of the following techniques when utilized to class level in feature selection for classifications? LDA, PCA, or both, or none of them? Which one? It's not, right? So, only L, LDA. Because PCA is not for classification. Okay, another one. Here, consider the following. Which model will choose for dimension reductions? PCA, correct. If you answer PCA only, wrong. Here, if we do LDA, do you think the direction of LDA and the direction of PCA are the same or not?
Yes.
Think in this specific case. Okay, what is PCA? What is the direction of PCA, please? This one
Yes.
or this one? PCA.
Yes.
It's not. If we do this one here, the projection, the variance is small. I have to do it in this one to have a big variance. Look to the variance, not to the class blue or red. So in this specific case, PCA direction and LDA direction gives better result. And they are the same directions. So in this specific case, both of them are correct. Clear or not?
Yes.
So PCA, look to the variance. LDA, look for the segregations between the two classes.
Doctor?
Yes.
I'm confused. Before you told this.
No, in this specific example. I said in this specific example. I know. Means how we can use PCA in this example, right? But here, what I said, look at the questions. For dimension reductions, to reduce the dimensions only. So if you apply PCA, you will get the projection on this one, right? If you apply LDA, you get the projection on this one. So both of them gives you the same data after projection. So both is correct. Next step. Consider the case where two classes follow Gaussian distributions with the center is given -1, 2, and 1, and they have the same covariance. Which of the following is the separating decision boundary? The decision boundary. What is the decision boundary? If you have data like this and data like this, how to separate between them? I need this one, right? Anything bigger than this or less than this. So in this specific example here, if you have -1 and 2 and 1 and 4, which line is the decision boundaries? So those are examples for the assessment or the finding. Look here, you have a data here, and you have another data here. The mean of this one is -1, 2, and the mean of this one is 1 and 4, right? Okay. But sorry, they have the same. They have the same variance. What does it mean? What does it mean, same variance? Mean the same shape. Same shape. Okay. So what is what is decision boundaries here? Look here. Just forget the question. How to do decision boundaries? Is it here? No. So what? Is this one, right? So do you think it is the middle of this one or not?
Yes.
Okay. Do you think it is perpendicular or not?
So we
Yes. Okay. So how to find it?
I think
Okay.
we should sum.
Okay. What is the midpoint here? What is the midpoint? The sum of the point divided by 2. -1 and 1 is 0. 4 plus 2 divided by 2 is 3. So the line should be goes across this one, right? Okay. The normal vector of this one, what is it? Is this point, yes?
Yes.
So it is equation of the. Do you remember equation of the line, please? Ax plus by plus c equals to 0. A and b are the normal vector, right? What is the normal vector here is 1 minus 1, it will be 2 and 2, which is 2, right? So we go back here. So we are looking for the direction. I can put 2, 2, 3, 3, 1, 1, doesn't matter. So it will be here, x plus b plus c equals to 0. It just goes through 0 and this. If you do this one as 0, and here's sorry, y. If you do y is 3. What is c here, please? So c should be? C is minus 3. So it will be at the end, x plus y equals to minus 3. Yes? So which one is? Sorry, minus 3 should be plus 3. Okay, so is the question is? Answer is B.
What's 2, 2?
Sorry?
2 and 2.
It is a normal vector. It is the 2 mean difference. This vector here. Because this vector is parallel to the normal. It just geometry, how to calculate the equation of the.
Finding the 0 and 3 in the beginning class, you can able to solve the question.
But just refresh you how to get the equation in general. Yes. Okay, which of the following is correct about the LDA? Which one is correct? It minimizes the variance between the classes relatively to the within class values. Maximize, minimize the variance is correct, right?
Yes.
Yeah.
Minimize the variance.
Within the class.
Between, minimize the variance between the classes relatively to the within class. I think it's correct. What does mean? Mean the minimize the values of each class. Within the classes. Later on, within the class, the variance. Okay. Second one, maximize the within class variance. Third one, maximize the variance between the classes relatively to the. Yes. So you maximize the variance between the class. Last one, is it not necessary to have a target variable for applying dimensionality reductions? True or false?
True.
Are you sure?
We don't need class level.
What is the target?
Sorry?
What do you mean? To have the target
Level. Target
Okay.
variable.
A target mean is level. Yeah. Yeah.
No, we don't need.
Yeah. This one, check. Dimension reduction algorithm are one of the possible ways to reduce the computational time required to build a model. True or false? What do you think? Is true or not?
False.
Tell me why. Okay. When you reduce the dimension, do you think the complexity will be reduced or not?
Yeah.
Yes.
Yes.
So, of course, yeah. If the data is small, we don't need too much calculation to do, right? This is why. So true or false? Thanks. Yeah, it's true, of course. All this one we do to reduce. Why we reduce? Compress it. To transmit image last time that we showed, we don't need to do all the pixels, right? Few of them. Okay, PCA can be used for projection and visualizing data in lower dimensions.
Yeah. True.
True, yeah, of course. Yeah. Clear? Because reducing the dimension, you can present it nicely, right? When you have 1 million features, or you have 3 features, it's different, right?
Yes.
Here, which of the following is true about LDA?
First one. Maximize distance between class and minimize distance between tokens.
Maybe all wrong, maybe 2 is correct, maybe 3 is correct, maybe all is correct. You see, these are difficult things, right? So sometimes multi-choice is not easier, when there is all possible candidates.
No, but it's A, right? It's A.
Aims to maximize the distance between the classes, minimize. Okay, B, what is B? Aims to minimize both distance between. For sure is?
Wrong.
No. Last one. Minimize the distance, for sure, between the classes. Aims maximize. So the answer is?
A.
Here, within the following components are true PCA and LDA. Both LDA and PCA are linear transformations techniques. Yes or no?
Yes.
I didn't say kernel, right? LDA is supervised, where PCA is unsupervised.
Yes.
Yes.
Okay, PCA maximize the variance, where LDA maximize the separation between different classes.
Yes.
3 is correct or not?
Yes.
Yes, so all of them is
Correct.
correct. Clear? They are the same thing.
Can we have all questions like this?
Yeah. What will happen when the angle value are roughly equals? What do you mean? PCA will perform outstandingly.
No, because every PCA
PCA will perform really badly.
Yeah.
Cannot say none of them.
Can't say.
No, for sure PCA is not good. It's performed bad. Because all the lambda are the same, I cannot compress anything. So of course PCA is useless in this case. Because what we want to do, we want to find PCA when the lambda are differences. One is big, one is small. Otherwise is no need, we cannot compress it. Here, PCA work better if there is linear structures. Yes or no? We don't have shape, something. Means the data is going like this. It's linear shape. Yeah. Circular, it is not. If the data lies on the curved surface and not on the flat surface. If the variables are scaled in the same unit.
It's normalization. That's right.
Because look, we are looking for the variance, right? Looking for the variance. This is kilometer, and this is nanometer. Do you think it does make sense? Right? So here the data will be all small, and in nano it will be really huge. So you have to be standardized, right? So do you agree with that? 1 and 3. Here, please. Imagine you are giving the following scatter plot between height and weight. Select the angle will capture maximum variance along a single axis.
Maximum.
Is it 0 degree, 45,
45,
60, or 90?
B. 45.
Maximum.
I think it's B, 45, almost. If you want to do the same question for LDA, what will be, please?
90 B.
LDA.
We don't have classes.
We don't have cassettes, so the LDA is not suitable at all. Clear, please? LDA when you have different classes.
Yeah.
So be careful about this. Here, which of the following options are true? Do you think we need to initialize anything to do PCA? Do you know what I mean, initializations? Some algorithm we need initialization, like for example, K-means cluster, if we do it later. You don't need to initialize parameters. PCA,
Dimensions that we want to reach, or like minimum, maximum.
no, any variable you need to initialize.
No.
You don't have, right? Okay, so first one is not. You don't need to initialize any parameters in PCA. Yes? PCA can be trapped in the local minimum problems. You are doing any optimizations? No. Can't be trapped into local minimum problems. Yes. So the answer is D. 2 and 4. Okay. Here.
Doctor,
Yes.
if we go back to the last question and it's LDA, it will be 1 and 3?
Which one is one?
No, the next one.
Back or going
No,
forward?
no, yeah, for
They're asking
if
about
it's the
the
same, but instead of
LDA.
PCA, it's LDA. If they're asking about the LDA,
Okay, LDA, we don't need to initialize.
we
We don't need to
don't
initialize.
need to.
Yeah, but here we are doing optimizations. Let me think. According, yeah, so here it becomes a problem difficult. Which, for example, what we did the ratio, right?
Mhm.
But I can do all the forms, so we don't know. Maybe we have problem of optimization for sure. We have it, yeah. Here. Which of the following method will result into better class predictions? If you use LDA, you get this direction. If you use PCA, you get this direction. It's giving on the plot. Okay, for sure, LDA, it is not the right one, right? Sorry, PCA, it's not the right one to classify. So it isn't. Even LDA is a little bit, yeah, B. Here, consider three data of 2 dimension like this. What were the questions? What will be the first principal component here? Which A, 1, 2, 3, 4? What is the principal component? But give me the direction of the vector. Okay, forget the possible answer. How to find the vector here? Roughly. 1, 1, right?
Yeah, it's on one, then it's
1, 1.
over
Or,
square root.
but if we say 1, 1, I'll tell you it is not.
It's unit vector.
Because 1, 1, it is not unit vector. We need to divide it by square root of 2. So it will be 1 of square root of 2. 1 over square root of 2 is the same thing as square root of 2 divided by 2. So the answer is can be 1 and 3. Doesn't matter the plus or minus, right? Clear? So you have to be careful about this specific. Is it clear or tricky questions here?
This one is.
Because the vector is 1, 1, but you have to make sure that it's unit vector. You have to divide it by its norm. The norm is square root of 2. You got the idea? Here. Do you think LDI 1 or LDI 2 is better? Or both or none of them? But I didn't finish the questions. If for classification or for feature reductions. You see? So what do you think here? According to the questions is separate between classes. So for classification, so which one is better? LD1 or LD2? 1, yes. 1 is clear, right? It's separating between the two. This we did last time. I'll not repeat it. Here, for PCA, what is the best? What are the option numbers of principal component in the below figure? Without compromising anything, but we can do reductions. Which dimension you can go? A, B, C, D? B, yes, it is B, because after B, the lambda is 0. There's nothing, right? Clear? So here, you see here, all the lambda are, what is the value of lambda here? 0. Okay? Here, PCA, is it a projection according to the left or to the right? So for PCA, do you think we are doing this or we are doing this?
This vertical axis. This one, yes.
This one, vertical projections, right? Not any other lines. So this one is not. Clear? I think there's a lot. No, the last one here. The most popular used dimensional reductions algorithm is PCA. Which of the following is or are true about PCA? PCA is unsupervised, correct or not?
Yes.
It searches for the direction that the data have the largest values.
Yes.
True. Maximum number of principal component is always less or equals to the number of features.
Yes.
Yes, correct. Because number of eigenvectors is number of features. So the maximum that we want is always less or equals. All the principal components are orthogonal to each other.
Yes.
True.
Because symmetry.
So I put the answer already, sorry. Okay? So this type of questions, please try to do it for the. I would do the mock exam for the midterm. So to be this type of questions, little bit. Most of them are like this, but most of them you have to do handwriting. There is no proofs. The proofs is just for your knowledge. Okay? Thank you.